in your purple packet, and I will work through the examples at the bottom. And here, just a little review maybe for some of you on absolute value. I can't do anything to what's inside the absolute value bars until I've isolated just the absolute value bars themselves. And that's how these problems differ from the other examples on this page. So step number 1, I would subtract 11, and then I have 2 times the absolute value of 3x minus 7 would be set equal to 8. Then I would multiply both sides by 1/2, and now finally I will have completely isolated the absolute value bars. So now each of these problems becomes this. The absolute value of 3x minus 7 is less than or equal to 4. The absolute value of 3x minus 7 is greater than or equal to 4. So I can take each of these and solve as we did before. First of all, I will use the 2-equation method, the bifurcation method. So I'll take what's inside. 3x minus 7 equals 4, and 3x minus 7 equals negative 4. So this will give me my 2 boundary points. 3x is 11, x is 11/3, 3x is 3, x is 1. So these are my 2 boundary points, and in just set notation, the solutions for the strict equality would be 1 and 11/3, and graphically I would just have 2 solid points at 1, and then the other solid point would be at 11/3, which is about 3 2/3. So that would be your solution for the strict absolute value equation. And now just to wrap it up for the sake of comparison, moving to the other cases, this is my AND scenario, my conjunction. So the solution set here, I would have my boundary points at 1 and 3 2/3. I'm looking for conditions that are simultaneously true, which means I'm looking for the continuous common overlap set of points. And then finally, the disjunction, the OR scenario. You have your boundary points of 1 and 3 2/3, but the boundary point marks a spot where you travel off in the direction of positive and negative of infinity with absolutely no overlap. Now when these problems are all mixed up together, the easiest way to keep it straight when you're trying to determine if you're shading between or if you're shading in the direction of infinity, the symbol greater than is always associated with the OR scenario. So OR is always associated with greater than. And the easiest way I can think of to remember this for learning purposes would be the letter R. Since OR contains the letter R, greater than contains the letter R, I think that's the easiest way to remember this. If you have to find a way to remember it whenever all the problems are mixed together. And the AND scenario, and is always associated with a less than or equal to scenario. Meaning this is true when your variable is on the left, you have your inequality symbol, and then the number on the right.